All eyes are now locked on the Tesla Model 2, the car many believe will redefine the global automotive industry when it arrives in 2026. For years, people have talked about Tesla's achievements in autonomous driving, software updates, or the promise of a future filled with robotaxis. But surprisingly, none of these are the real reasons the tech world is buzzing this time. What's truly capturing global attention is something far more practical and far more disruptive: a fully capable Tesla, priced around $10,000. A figure that was once considered impossible for an electric vehicle. A price point low enough that nearly anyone could afford one. For the first time, millions of new buyers could realistically join the EV revolution. But the big question is obvious. How can Tesla possibly pull this off? How can a company that builds high-performance electric vehicles suddenly offer one at a price that competes with used cars? How can they maintain profit margins while still delivering a car that is durable, reliable, low maintenance, and hassle-free for owners? Even more importantly, how do they do all of this without sacrificing Tesla's signature performance and efficiency? The answer lies deep inside Tesla's production lines. It comes from a combination of breathtaking engineering decisions, manufacturing innovations, material sciences, and factory logistics that most people never get to see. Every module, every conveyor, every standardized fastener, every casting mold, and every CAD detail plays a crucial role. When all of these techniques come together, the result is a production system so optimized, so ruthlessly streamlined, that even something as ambitious as a $10,000 Tesla suddenly becomes possible. But how exactly does this hidden world work? What secrets inside the manufacturing process allow Tesla to achieve a level of cost reduction most automakers cannot even imagine? Before we dive into the shocking production breakthroughs that make the Model 2's price reality instead of fiction, remember to subscribe to Westech so we can reach 243,675 subscribers. Turn on notifications so you never miss upcoming videos on Tesla's technology, EV breakthroughs, and the future of automotive engineering. To understand how Tesla makes the Model 2 a low-cost vehicle from the very beginning, we must go all the way back before the first machine even touches a piece of metal, long before a robot welds, stamps, paints, or assembles anything. The Model 2 is refined inside a computer through CAD modeling using special principles called design for manufacturing and design for assembly, known in the industry as DFM and DFA. These principles determine what percentage of the car's cost is locked in before any physical prototypes exist. Many people don't realize that 70 to 80% of the total cost of any product is set at the design stage. That means that the majority of the Model 2's cost savings happen before the factory ever begins its work. Tesla's engineers intentionally design the model so that it is extremely easy to build and extremely easy to assemble. They remove redundant parts, unnecessary brackets, extra clips, and overly complex structures. They combine multiple pieces into single parts wherever possible. They minimize the number of steps that workers or robots need to perform. The total number of materials, fasteners, and special tools required. Every reduced step saves dollars. Every eliminated part removes cost. Every combined assembly improves speed and lowers risk of defects. To better understand this, consider the evolution of Tesla's manufacturing from the Model 3 to the Model Y. The rear underbody of the Model 3 used around 70 separate steel and aluminum panels. Each of these had to be stamped, transported, positioned, welded, inspected, and aligned. It was complicated and expensive. But in the Model Y, Tesla replaced all of that complexity with just 2 large cast aluminum pieces. These replaced 169 individual stamped parts and eliminated over 1,600 welds. That's not a small improvement, that's a revolution in automotive engineering. And the Model 2 takes this approach even further. Areas of the body that used to require dozens of small parts will now be made, using single-piece castings or simplified structures that reduce part count dramatically. With each part eliminated, Tesla removes stamping steps, welding steps, conveyor transfers, inspection points, and potential failure points. The fewer parts a car has, the easier it is to build, the faster the assembly becomes, and the cheaper it is to maintain. For the buyer, this means fewer breakdowns, fewer rattles, fewer warranty claims, and fewer headaches. Another major step Tesla takes is standardizing fasteners, screws, clips, and joints. Instead of having a different type of screw for each part, like many traditional automakers, they aim to use only 5 to 7 main fastener groups repeatedly across nearly the whole vehicle. This allows Tesla to order fasteners in huge quantities at lower cost. It also simplifies the assembly process tremendously. Workers learn faster. Robots need fewer tool changes. Inventory becomes easier to manage. Assembly errors drop. Maintenance becomes cheaper. And owners benefit because replacement parts are easier to find and far less expensive. Tesla also designs many components to naturally align. When a worker or a robot brings a part to the frame, the surfaces, pins, and geometry guide it into the correct position automatically. This eliminates the need for precise measuring and reduces the chance of misalignment. Saving just 1 or 2 seconds at a single assembly step may not seem like much. But when hundreds of steps exist in every car, and hundreds of thousands of cars are built every year, those seconds multiply into massive labor savings. This brings us to another fundamental question. If Tesla reduces cost at the design phase, what factory steps allow the Model 2 to be manufactured at large scale and high speed? The answer lies in how Tesla divides the Model 2 into a series of modules. Instead of building the car by attaching thousands of small parts to a moving frame, this traditional method used for over 100 years, the Model 2 is built from large specialized modules assembled separately, then brought together at the main line. The Model 2 includes modules like the drive unit module, battery pack module, interior module, and front and rear structural modules. Each of these modules has its own dedicated assembly line. The modules are nearly complete, often 80 to 90% finished, before being moved to the main body line. This revolutionizes the final assembly process. Now, instead of installing hundreds of individual parts like motors, cooling tubes, wirings, brackets, and electronics, workers simply integrate large modules that are already standardized. Bolt patterns match. Connector ports match. Alignment pins match. Everything is designed to snap or bolt into place with minimal effort. This modular architecture dramatically boosts speed, lowers error rates, and enables Tesla to scale production without massive extra investment. The drive module, which includes the motor, inverter, and gearbox, can be produced at incredible speeds, sometimes in under a minute. Meanwhile, the battery module is built on a separate line, where the cells, cooling plates, structural components, and electronics are assembled with high precision. The interior module allows seats, dashboards, wiring looms, and sensors to be built together instead of individually. When these modules meet the body, integration becomes a series of quick, highly repeatable steps. This design also allows Tesla to make inexpensive versions of the Model 2 without retooling or building new factories. By swapping in smaller battery packs, simpler interiors, or low-performance motors, Tesla can create ultra-budget versions instantly. Same robots, same fixtures, and same production lines handle all versions, meaning cost remains low, regardless of configuration. But modular design alone isn't enough to save billions. Tesla also reimagines how materials move inside the factory. In many traditional factories, 30 to 40% of production time is wasted on non-valued activities like waiting, transporting parts, finding components, and navigating bottlenecks. Tesla eliminates much of this waste by creating near one-way material flow. Parts move logically and efficiently from one stage to the next without looping around the building or waiting in storage areas. This alone saves huge amounts of time. Tesla also uses kitting, preparing sets of parts specifically for each car configuration. Rather than workers spending time searching through bins of parts, every car's kit arrives exactly when needed. This reduces pick time and can cut indirect labor in half. The result is smoother workflow, fewer mistakes, and faster production. Another crucial advantage comes from Tesla's selective use of automation. Instead of trying to automate everything, which can lead to expensive equipment and endless debugging, Tesla automates only the tasks that robots perform better than humans. Heavy lifting, repetitive torquing of bolts, precise welding, adhesive application, and structural assembly steps are perfectly suited for robots. Meanwhile, humans handle tasks that require fine visual judgment, delicate alignment, and careful handling. This balanced approach keeps investment low, quality high, and production stable. All of these steps address speed and cost, but there is another crucial factor: quality. Tesla ensures quality not at the end of the line, but at every step along the line. This is a major shift from traditional manufacturing, where most quality checks happen after the car is fully assembled. Tesla uses sensors, cameras, torque monitors, gap measurement systems, and real-time data analytics to catch issues instantly. For example, each bolt's torque is measured as it is tightened. If the torque is off by even a small amount, the system flags it immediately. Cameras check alignment, fit, finish, and positioning. Sensors verify whether connectors are fully seated. This method reduces rework, avoids scrap, minimizes defects, and ensures the Model 2 is built right the first time, throughout the entire production line. Tesla tracks statistical deviations using real-time analytics. If a pattern emerges, such as a bolt consistently requiring rework or a panel showing a misalignment trend, Tesla adjusts the process immediately. This ensures a consistent, repeatable standard of quality across every model to manufactured. All of this smart design, reduced part count, modular engineering, optimized material flow, selective automation, and integrated quality control comes together to create a manufacturing system capable of delivering a $10,000 car without sacrificing Tesla's brand identity. Traditional automakers cannot easily replicate this because doing so requires rebuilding their factories, redesigning their cars from the ground up, and embracing an entirely new manufacturing philosophy. The Tesla Model 2 is not just cheaper because it uses fewer parts. It is cheaper because it represents a complete rethink of how a car should be designed, engineered, assembled, inspected, and delivered. Tesla didn't just create a new car, they created a new way of building cars. The result is a vehicle that millions of people can afford, produced at a scale that could reshape the entire automotive industry.